Hi everyone, I'm David. I work as a developer at Heijn, and today I want to tell you something about the BFF. It's not on my monitor yet. Do we need to switch the screens to my... all the way in the back. Okay. So yeah, obviously the title of my talk is based on the Oprah Winfrey show. I don't know if anyone's familiar with this show, but in this specific episode, everyone got a gardening audience and everyone was happy. And I want to talk to you about why you should be happy with receiving a BFF as a front-end developer. First, I want to talk about the current situation that we're having at Heijn. Click. So, when I first started, it kind of felt like this. This was me, and that was the big Java front-end application that we were working on. So it was based on several principles. It was a monolith application, so one big application that has to be deployed as one. The backend was written in Java. The frontend was written in Backbone. And most application logic was defined within the Java code. And that was actually the biggest problem with this architecture, that we didn't control the application logic as front-end developers. But it was already API first, so that was a big help. So just to recap, this is the Heijn website. We have several domains, products, bonus, Alejandro books, huge website. And just to simplify things in the picture, basically the old situation, it looked like this. So we have the backbone application, we have the gateway, and it talks to the Java monolith application where most of the logic is defined. Meanwhile, gotta get used to this clicker. Meanwhile, the backend was already building some microservices. So for example, they were developing a product service, a member service, and the monolith was actually a consumer of these APIs. So we were still chatting to the Java application, so not directly to the microservices, but the monolith was already using the microservices. So we had several challenges with this setup. So deployments, we had to deploy everything in one go. We have a lot of tests failing when we change some stuff. Performance is not ideal, also because we use an old framework like Backbone. Maintenance, you can imagine if you're working with everyone in one big application, it's really hard to tell who's the owner of what and where you can find something. So maintenance was a big problem, and ownership as well, because we had all the teams working on the same application. The teams were not really dedicated to a specific subdomain of the application. So we wanted to change some stuff. So we said, okay, what are the most important things for the new architecture? So we want to improve the ownership. We want dedicated teams working on a dedicated domain. We want to replace the website step by step, because the website is so big, you cannot replace it in one go. You need to do it step by step. We want to use modern technologies to speed up the website, and also move the application logic to the front end. And this is where the BFF comes to play. So I want to guide you through all the different steps and how we actually done it. So first, let's talk about rebuilding per domain. So once again, we have these domains. So for example, account, content, products, bonus, Alejandro books. This was all within one application. And what we said, okay, it will be easier to split these into several applications so we can control them within one team and also have their own deployment pipeline. So basically, we look back at this situation, the step that we just made. Okay, let's say, okay, we want to create an account application. We can move it next to the backbone application. And then, for example, we can use a reverse proxy, and we can say, okay, if you go to /account, we can actually redirect you to the account UI, and otherwise you end up at the backbone application. But now we still have a problem because it's still using the same API, the Java API, the monolith API. So we do have some freedom just on the React front-end side, but still most of the application logic is actually defined within the Java application. So now we want to move the ownership of the application logic to the front end. This is kind of how I reacted when the application logic moved to the front end, because it makes things more fun for us as a developer, and we get way more flexibility and freedom. And also now you can imagine that the Java API, it was mostly focused on the web part, and that's not ideal because we want to move the product service, for example. We also want to reuse it for maybe offline or the app, and this allows us to do that we move the application logic to the front end in our BFF. So yeah, the BFF, what's the BFF? It's not this one. So I will just let you read this. I'm not going to read it for you. And then you're going to think like, what? So it's actually a layer between the APIs and the front end. So yeah, what? Some examples that we do within the BFF. So we do data aggregation. So if you can imagine if we do a call, for example, we want to get some products, we also want to get some member information, like are you logged in or not, and then we also want to combine that. We want to send your member token to the product service, for example, and then get results specific for you. So we combine different microservices in one call, and we aggregate that data within the BFF. We also normalize some data. For example, now the product service is no longer built for the web. So the output is really flat, and it's, yeah, you can say more or less stupid in our case, because the web doesn't, I see you laughing. But for example, we need several other things. So for example, we get some properties for products, but in the front end, we actually want to show some icons. So we want to normalize the data so that we actually can use the data within the front end. And also the authorization is also handled on the BFF. So now we can move all of these things out of the Java monolith and also out of the front end, and we can put it in a layer in between. So if we look back at this picture, it will look like this. So now we have the backbone application, which still uses the Java API, but now we also have an account BFF. So the account UI, it talks to the account BFF, and then it skips the Java monolith, and it talks directly to the member service or the product service or whatever service you need. Click. Okay, and another important thing is that the BFF is focused on one app. It's coupled to one app, because the data for the member servers, the output could be different than the BFF for the products. So let's say we also want to create a search application. We actually create a new BFF and a new search UI, and this also gives us way more ownership, because now we have one team working on the search UI and the search BFF, and they can integrate the services how they want. And we also have the account team, which has their own application. So then we want to implement some modern technologies. This is what I imagine with modern technologies. Area 51 hacking in process. So first of all, we said we want to introduce TypeScript. So I don't know, who of you is familiar with TypeScript? Quite a lot. So the backbone application was written in JavaScript. And one thing that we said is that the backbone application was one big application. Now we want to split up things in different modules. but that also has some caveats, because if you want to import a module, you don't really know how to use it. So with Typescript, we can also export interfaces, and it will make your editor smarter in terms of understanding what the module does, and also if you upgrade something, you know what exactly breaks, because everything is typed. And we can also share interface between the API and the app. So I'm just going to go back to this picture. If we have the account BFF, which consumes several APIs, we can actually export the interface. So that's the interface, what will be the output of the API, and we can consume that interface again within the account UI. I will show you an example of that later on. So, for example, we have an API call which requests some products. So the search UI, it actually calls the search BFF, and then the search BFF does the logic like authorization, and then actually calling the product service to retrieve the products. But then we get the products as a really flat array. Just everything is in there, but it doesn't really tell the web client what you need to do with it. For example, like I said, we can have some properties that stand for icons, and we can normalize the data to actually convert it to icons or icon properties. And then we can output the product normalized. And this is also a really good use case where you can apply some tests, for example, because we can add some unit tests to see if the data is actually properly normalized. And then we output the products normalized within the API of the search BFF, and then we can serve it to the search UI. So for example, in the search BFF, we have an interface, product normalized. So we have from properties, for example, an ID and title, and also an availability, discount, all information you need for a product. And the unnormalized is converted to this interface, which will we, this one we will expose from the BFF. And then within the search UI, our React application, we can actually import it from the module. So we have a shared library, it's called core services, and there we have a definition for all the models and controllers you can use within your BFF. So, for example, we have one for the products, and multiple teams can use it because it's in an NPM module, and you can import the model and controller within your API, but you can also import the interface within the web. And then you actually have the typed output of your API. And then we can say, okay, we want to map over the items. And then, well, here, the product normalized is the data you're getting. And another cool thing is we can also use this within the product card, and we can check if all data matches. So, we also decided to use React. So we were first dealing with Backbone. And Backbone was working with inheritance. So you can imagine within Backbone, if you want a banana, you get a monkey holding the banana and you get the whole jungle with it. Which is not ideal, because if you want to make an adjustment to the banana, then you also adjust the monkey and the jungle. And basically we want a more flexible solution, because, for example, we have several definitions of the product card, but internally they might use the same elements, but you still want to keep them separated. So we want to compose elements, and that is where React actually fits in really well. It also has a really small footprint. Like I mentioned at the start, we were dealing with speed issues, performance issues. And this allows us to optimize that as well. We can also implement things like server-side rendering. And it's just a few. So also we defined an architecture, but still we want to have freedoms within the teams. And React is just a few, and basically all teams, they can go their own way and choose third-party libraries or make their own libraries, what they actually want to do with the implementation. So they're still quite free, even though that we have a set path like going for React. So this is an example of, we have a library called Web Components, and there's a collection of simple components. So it could be a product card, it could be a label. You can build your way up. So here we have the product card, and the product card actually has some elements. So it has controls, description, image, all the things a product card consists of. And then you can see that below, in here, we have several product cards. So we have a compact card, we have a full card, but we also have one for the Alejandro box, which is slightly different. And the cool thing is because they all reuse these elements, they basically just add some other element, like one other element, or they adjust some styling. And here we can actually reuse most of the components. So we have a product card full, and we have one for the Alejandro box, and they're actually really similar because they all use the product card image, for example, the discount label, and this way we can compose new elements without actually affecting the inner elements. And another cool thing is that you can unit test all of these elements by themselves. So all these components are pretty dumb. They just take an image, for example, and they render the image, and that's something which you can unit test really well. So then we also have a set architecture per application. So the application would be search, for example, or it could be products or account. And we have 4 projects within every application. We have an API, which is the BFF. We have a web client, which also has a node server for the server-side rendering and the React server, the React application. We have Nginx as a reverse proxy, and we have a test project. So the API, which is the BFF, it's built on Node.js and Express. And like I said, it's really simple. It's just data aggregation, authorization, and it's a small layer between the user interface and the microservices. Then web, we add React on top. So we also have Node.js, but we also have a Node server here specifically for the server-side rendering. And especially because Node.js is single-threaded, you don't want to combine the BFF authorization, normalization with the server-side rendering, because you don't want your app to be served slower because the BFF has a performance issue. And then we have React. For testing, we recently switched to Cypress. So first we were working with Nightwatch, and I don't know if you're familiar with Cypress. Okay, quite a few. So far it works really well. I think the only disadvantage is that it only runs on Chrome and Firefox right now. So hopefully in the future they will support more browsers. And of course with Nightwatch you can also connect it to Browser Stack. You can run it on multiple devices, but Cypress is way more stable. And with Nightwatch we were dealing with a lot of issues where data was not loaded yet because it runs on Selenium, which is not the best solution. And then ownership. So now we have everything split up in different teams, but how do we define the ownership? Because ownership is also, it goes further than the teams. So we have sleeper cells. So I already told you that, for example, we have the core services project, but we also have a web components project, and we also do testing. And you do want to have some form of uniformity in those things. So we introduce sleeper cells. And so far, we have one for testing, for the web components, and we have one for the architecture in general. Basically, it's a group of developers from multiple teams, or anyone can actually join, testers. And basically, what we do, we discuss where do we want to go in the future, and what are some new things that we want to introduce, and what are some problems that we're running into within the teams. And the things will be discussed here, and then the knowledge will be given back to the teams because there are developers from every team in it. Then we have our own Artifactory, so we split everything up in node modules. And we use the Artifactory to serve as a host for our NPM modules. And then we also want to switch to the DevOps way of working. Some teams already do it, some teams not. But basically, for example, I'm working in a team for search, so we want to have the product service in the team. We want to have the search, React, and BFF within the team, and then we have the control as a team over the entire search application, which also allows us to do our own deployments. We're also the ones who will can receive a phone call in the middle of the night if something goes wrong, I guess. But it allows us to maintain the ownership of the project. So performance. Another meme. So I think that the car is the backbone application, and Flash is the new React application. So we have a shared app shell, which is also an NPM module, and the app shell is basically a bootstrapper for your Node application, which means everyone has the same starter application for serving your Node application, your React application, I mean. And this allows us to have some sort of baseline for every team, some uniformity. Okay, this is the minimal product, and everything else can be added within the app. So the cool thing is we can actually measure what your application, your specific application search or account does to the front end, to the user, to the performance. So we can actually measure the difference between the blank app shell and all the features that you build on top. And that way we can figure out, we can easily locate, okay, the performance issue might be coming from this specific feature. And then we also introduced Dynatrace. I don't know if you use it at bull.com. Nope. Okay, so Dynatrace is a tool. It's actually really cool because we run everything in Kubernetes. It attaches to the containers, and basically it measures the performance per container. So if you look at the UI of Dynatrace, you can actually follow a user request all the way through the different microservices that it touches. And you also see how long it takes to go to a specific microservice, and that also allows us to find performance issues and locate them, like where they are actually located. That you just sometimes, if you don't use Dynatrace, for example, or a less advanced tool, then you know there's a performance issue, but you don't know where exactly it's coming from. And with Dynatrace, it's really easy to locate. Okay, it might be in this microservice or this specific request with a user having this data. So that was it. Any questions? Sorry?
Are you going to be around for the whole space summit? Because I guess we cannot cover all our questions.
Ah. Yeah?
Yeah, quick question. I saw that you chose React.
Yeah?
What was the why you went for React and not one of the other component-based frameworks?
So, for example, Vue.js or
Vue or
yeah.
Angular or
Yeah.
I'm just interested in what was the rationale behind it.
Yeah. Well, in my opinion, it's also a matter of. Oh yeah. So the question was, why did we choose for React and not for another framework, which another component-based framework like Angular or Vue.js? And I think it's for several reasons. I think the most important reason is preference, that we as developers prefer React. And another thing is, so in my opinion, Angular is more towards if you're dealing with a lot of data, and our front end is actually quite stupid. So it doesn't need a framework like Angular. And another thing is we are with a lot of developers. We started a year ago, and a year ago Vue.js wasn't that big yet. It's also easier to find React developers instead of Vue.js developers. But I think Vue.js, in my opinion, is a great option as well. Yeah?
Why the BFF and not a microservice?
Okay, so the gap that the BFF tries to fill is actually the gap between the UI and the microservice. And if you communicate directly from your application to the microservice, you're going to deal with a lot of issues. For example, you need to do the authorization from the client as well. And now we have a specific dedicated server which deals with the authorization and the normalization of all the data. You can combine calls within one API call to the BFF, that the BFF actually calls different microservices, and you extract the complexity of that from the user interface application to a specific application. And it also makes it faster because, like I said, Node.js is single-threaded, so you don't want to have that logic in a server which also deals with the server-side rendering, which is quite heavy for a Node server. You want to extract it to a different server, yeah. Mm-hmm.
Is the BFF always made for one specific front-end?
Yeah. So yeah, the question was, is the BFF always made for one specific front end? And it is. It's for one application. So of course, an application could have several pages. For example, You can have a products application which has the product detail page and the product overview page, but the BFF is strictly for that application, yeah.
So you don't reuse, for example, when you have the web and an app,
No.
you don't reuse the same BFF.
No, because the reason for that is, for example, they can update the product service to version 2, and we as a web, we want to stick to using version 1, and the app might want to use version 2. So if that logic is combined, if it's reused for the app and the web, then web is forced to upgrade if the app wants to update their application to version 2. Mm-hmm.
I guess with like anytime you have a layered architecture, you always have the like when you start, you might want to have less layers because you think that they might not be necessary.
Yeah.
What is the point where you decide, okay, we should really put a BFF in here so that we can, because we actually have something to gap.
Yeah. Well, I think the biggest reason also why we introduced the BFF is to bring the ownership to the team. And because we have the BFF also within the team, we can actually decide what the output of the BFF API is. And for example, the product servers might be reused for several applications, but now we have an API specific to our application, so it's less fragile to break. And yeah, that's like a layer we want to put in the team and not somewhere else as well. I don't know if that answers your question, but
Well, what if you have a backend?
yeah.
The products I assume are also used for other things, indeed.
Yeah.
What if it's at the start, it's only used for this specific application?
Yeah. So yeah, of course you can decide to build it within your team first, and then if it's reused among several users, then you can actually move it to a different layer. That's also the way we develop. So we first develop within our application. For example, if we want to create some middleware, we develop the middleware in our application. If we notice, okay, this is something that another team needs to reuse, we bring it to an NPM module so that it's reusable for other teams. That was it?
I have one question.
Yeah?
You start your presentation with you next to this huge building.
Yeah?
That apparently is no longer the case, I assume. If you want to find a new picture of yourself where you currently stand, what would it look like?
Yeah, of course.
A lot of tiny buildings, maybe?
Yeah, so it was first one big square, and I think the best way to visualize is that actually the square has been broken up in sub-squares. So you have several cubicles, and every team is responsible for one cubicle, instead of the whole team being responsible for one big cubicle.
And does the small cubicles have smaller ones inside? Like some for the API and some for...
No. Like it's specific to one domain, so I think I would see the cubicle as one domain. Yeah. Yeah?
Are they all separate applications in terms of UI? I mean, do you have a shared library, or are they all modules or like standalone applications?
Yeah, so the question is if everything is a separate application or something is shared. So we have our own NPM artifactory where we share some components. So for example, the web components, the product cards, they're shared between all the different React applications. And we use semantic versioning to keep track of what's happening within the NPM module. But then every search application or account application, that's a specific application for that team. So that is a new application, yeah. Yeah, it depends what flow you have, yeah, but you would have a page load if you switch to from account to search, yeah.
That was it. Everyone, please, big hand for David.
Thank you.
Thank you.